as Bixi, you just heard a lot about international standards in data centers, but Bixi also has a data center standard. Just to remind, they do not conflict. In fact, we've had each other's documents to make sure that they say the same thing. So the Senelec is going to say what to do, Bixi is going to say how to do it, right? Except on the best practice parts where Bixi will not have anything there. But they are complementary. So, my name is Gautier Humbert. I'm currently the Bixi Mainland Europe Chair. And for this presentation, I'm doing it as Legrand, where I am responsible for standards. I actually work on a lot of the standards that Mike is in, but if you see his titles, it says leader, chairman, all that stuff. I'm just a groupie. I follow along. So, this is about PoE, single pair Ethernet, and how it's going to change the design of our building communication infrastructure. So, PoE is nothing new. It's been out there for a while. And why is there suddenly a hype about PoE today? We're all talking about it. Well, it's mainly because of IoT. Everybody's talking about IoT, and we know there's going to be a huge growth of connected devices. All those connected devices are going to need connections to the network somehow. This is how we do things currently in our buildings. If you open the false ceiling in any building, you're going to see a whole bunch of proprietary cabling systems. Where's my mouse? Down there? There. Proprietary cabling systems. They go back to their own controllers. So if you need to add a device, it needs to be on that same cabling back to a controller. And if they want to communicate together, it has to go back out of the controller to gateways, to the cloud, to whatever you want. This is not the future. This is the past. We don't want this anymore. What we want is basically what structured cabling has allowed. Connect any device you want on the network. It goes back to a switch, and you don't need a physical controller or gateway. What you just need is a software-controlled environment. If you go back a few years, 20 years maybe, telephony systems went into our cabling system. PABX were proprietary, were separate. Today, it's all about IP phones, Skype. You don't need separate systems anymore. Well, it's about time that the rest of the building came along that same system. So why did it work? It's because we created those 7 layers in the OSI model. Because of this, it separated each layer, which allowed us to have independence between them. You no longer had to buy the same brand for everything. It was non-proprietary. And first we had the data, then we had the wireless access points that came with that system. In between, we had voice over IP. Today, everybody's using Skype. And in France, you can no longer get an analog line to your home. It's impossible. They won't allow it. You have to get an IP line. IP cameras came along. Video, everybody's doing video streaming today. That's over an IP network. So we basically accept it as a good solution. And what we have to do is break the silos. This is the term that we keep hearing. This is the intent. If we break the silos, we allow everything to go on the same network, and it makes it easier. But this is also the difficulty, is because those silos today are not only about material products, they're also about responsibilities. So there's a lot of different people involved who are saying, no, I don't want you to touch my stuff because you don't understand it. So we have to get this opened up, break those silos to make sure everything works together. So this is the only way to get those systems really to be able to communicate to each other and stop proprietary systems. Stupid example, I have an alarm system. It has motion detectors. Why can't I use those motion detectors to also control my lighting? It could do it. The only reason it's not doing it is because there's a silo. So this is our intent in the industry, is to change this. So now, we need devices to communicate together, and we need power. So this is one way of doing it, right here. If you say you bring the alternative power, which is basically 2.2 kilowatt capacity on the electrical line, to a device which only needs less than 100 watts. Everything in the ceiling is generally less than 100 watts, much less actually. And now we're saying that all those devices, they also need data. They're all going to be connected, whether it's the light, HVAC, anything. Or you can just bring both power and data on the same cable, which is simpler. Well, it's kind of obvious. On option 2, I don't need the certified electrician. I don't need a whole bunch of infrastructure. It's just a lot simpler for everybody. Plug and play. And what does the industry say about that future? Well, this is the Smart Buildings Alliance. They are basically defining smart buildings and smart cities for the future. And they say that what everybody needs is a service on top, right here. To do this, you first need to do the right network architecture and the right security. And all this is going to be based on the right systems of cabling. Certainty. Buildings will be based on an Ethernet infrastructure. That's a certainty because that's already the case today. You go in any building, they have an IT room with Ethernet equipment inside. Today, Zigbee, BACnet, KNX, OCF, and Thread have all agreed to switch over to an IP infrastructure, Ethernet. They've all agreed to do this. So all of these systems will remain as applications over this infrastructure, no longer as proprietary systems. And this is the vision of the building of the future. Stuff which is at this level here, we're still going to need alternative current to plug in those devices that consume too much energy, or just because that's still the way we're buying those products. In the ceiling, AC will gradually disappear. AC will gradually disappear. And I work for Legrand, believe me. Saying this 5 years ago, I would have got shot. Today, everybody admits it. Our ceilings will go to DC. It's only a matter of time, because we don't need so much power. In between, at this level here, where I have to do the switches on and off, stuff like this, it's going to be wireless. And this is just to make the buildings more flexible. You don't want to have those fixed wires in there, you want to move things around. And if it's possible, it's going to be battery-less. The technology already exists from multiple companies out there. So, PoE, it's going to go over PoE. So what does PoE provide? Well, a whole bunch of power. So from the Type 1 today to the Type 4, which was ratified last year, if I remember right. Then, remember the first types only had 2 pairs for power, 2 pairs for data. And in our standards, we talk about the current per wire. So 1 pair is 2 wires every time. Today, the latest ones, they allow power and data on 4 pairs. And then these are decomposed into 8 different PoE classes right here below to have all the different options of power depending on the devices that you need. PoE safety, this is a big question. Electrical guys, they say, no, we don't want PoE, it's dangerous, don't touch it. Well, basically, 802.3, the IEEE guys who basically ratified the PoE devices, the switches, they say it has to have an electrical isolation. Complete isolation between the IT side and the electrical side. So there's no risk on the device. If you use devices like this, which have a complete isolation, the electrical standards will say, well, this is an SELV circuit, safety electrical low voltage. So that's defined in there. And that means you can use it according to an SELV definition in the standards. Those say exactly where to put it. And then there's the audio-video standards, which also will have limits, which are the same ones, and we're going to call it an ES1. So the standards are out there. We just have to say, well, this meets this, and it's there. So PoE is safe, we can install it, we can comply to regulations. Now, what's the issue with PoE? Well, when we send power in a conductor, we're going to have a creation of heat because of resistance. Now, the cable is already at a certain temperature because it's in the false ceiling, in the hot eye, in the data center, wherever. and we're going to increase that heat. And we need to know how much. In the standards, there have been some tests done, and those are pictures from the standards right here on measurements of the temperature increase. Our structured cabling systems are defined from minus 20 degrees to plus 60 degrees. If we exceed 60 degrees, we cannot guarantee performance. So this is going to be our limit. As a reminder, electrical cables are defined to 70 degrees. Now, we're going to look at a standard here, which is a draft 14673-2, which is actually, do I have it here? Which is actually identical to the EN standard, 5174-2, which is ratified. I have to be very careful what I say here, because the main guy behind this is sitting right there. He wrote most of this. So it's stating that you have to evaluate your cabling to support maximum power on all cables. Maximum power means 500 milliamps per conductor. Then your installation can be of 3 categories, RP1, 2, or 3. Now, what's the difference? It's about control. Imagine you find out that your installation cannot support full power everywhere because your cables are going to overheat. It means every time you connect a device, somebody has to take responsibility and say, yes, you can connect it, or no, you cannot. That's very complicated. Imagine there's a guy responsible in every building to manage that infrastructure, and you have to go to that guy before you plug in an IP phone. That's not practical. So this is RP1 and RP2. It means you set limits and you control, and you need to manage this during the life cycle of the building. So this standard is going to say, yes, but there's the RP3, and in RP3, you don't need to manage it. Your infrastructure can accept 100% of power on 100% of cables, and there will be no problem. In that case, you do not need to manage connection of devices. You do need to manage when you add cabling, of course. Make sure you do it the same way that you did before. Of course, you do need to label the installation so people know what category it is. And to comply to the standard, you're supposed to be RP3. So really, the standard is telling you you have to do RP3 so you don't manage it. If you can't manage RP3, then it's because you did your best, but you can't go all the way. Now, how do you calculate it? You're going to base the 500 milliamps. Irrelevant of PoE, that standard is going to say bundles of 24. And again, I'm talking here about these, the ISO standard, but it's the same as the Senlite. They're identical on all these points. Maximum 24 cables per bundle. But your bundles of cable, in some places, they're going to cross over some fire-rated walls, or they're going to come together in the cabinets. So the calculations will allow you more than 24 cables per bundle, of course. And there's a formula that's going to tell you the temperature. So this is a very horrible formula, but it just basically says, take the temperature of your cables on that section here, then take the temperature on that section here, and in that section, and you average them. And this is your cable temperature. Now, how do you calculate that heat increase? Well, there's another formula in there, and it's going to say, well, you're going to take into account the conductor diameter. The bigger the conductor, the lower resistance, lower heat. The diameter of the cable, the bigger the cable, the more heat can evacuate. Then the number of cables in your bundle, that's going to block your heat. And of course, the type of cable management. If it's a conduit, it's blocking your heat inside. If it's a wire mesh cable tray, the heat can evacuate. Of course, we know nobody wants to use such formulas, so the standard simplified it for you and created tables. So you can just read the tables. This gives you a good estimation, and if you want more precise, there's an annex, and if you want even more precise, there's another document. But all of us, we just want simpler. The simpler, the better. So here's simpler. This is an oversimplified system, but it gives you a good idea. I'm going to take a bundle of 24 cables Cat6, and I'm going to put them in a wire mesh cable tray. Or 72, let's make 72. 72 Cat6, and I have a temperature increase of 9.5 degrees. Okay. Now, if I put that same bundle into a conduit, I would have 15 degrees increase. Some of those can get quite high, but you do have to realize that nobody puts 216 cables in a bundle in a conduit. That just doesn't happen. We have to write this in the standard, but we know nobody's going to do it. Some of those are in red. Why is that? This is a temperature increase. And it is based on the fact that the environment temperature is 20 degrees. So 40 plus 20 is 60. If your cables exceed 60 degrees, we no longer guarantee performance. So you are not allowed to use those. But depending on your environment, you might not be allowed to use some of the other ones. If your environment was not 20 but 40, it changes things. And then you're going to adjust your temperature according to the bundle shape. If it's round, you're finished on that calculation. But most of the time, you're going to make like a rectangular bundle, right? Like here, so the width is wider than the height, so you're going to have a derating, and you're going to lower that temperature by that coefficient. Finally, you verify the solution, so you add your temperature increase to the ambient temperature. First of all, make sure it is not above 60. Now, what if it is above 60? What's the risk? And we need to remind, there is no risk to people. You're not going to kill somebody because you did this wrong. Your only risk is that your cables will not deliver the performance, and that the cables will age faster. But they will not suddenly catch fire. You need hundreds of degrees before they do this. We are nowhere close. So doing a PoE cabling, you are not putting anybody's life in danger if you do it wrong. Absolutely not. Then you calculate your maximum length based on that temperature. Ooh, what's this? Permanent link is always 90 meters, right? No, it's not, and it's never been. That table here has been in the standard since the beginning. Since the first standards in the 1990s, it has always been written that you need to derate based on temperature. But nobody followed it. Nobody was aware of it. It was not that important in most cases because we were not having so much power and so much heat. But now, let's take our ambient temperature in the ceiling, which is not 20, but maybe 30 degrees. And we add our bundle from before, which was extra 10 degrees, which makes our cable temperature 40 degrees. So we are now 40 degrees, maximum permanent link, 80 meters. Be careful, we do need to reduce that distance. At this point, if you have exceeded the temperature that you wanted, or you cannot have your links shorter because you need your long links, you need to go back to the drawing board and look at your options. So first thing is, did I really calculate my temperature as it's going to be, or did I calculate the worst case of the worst case? That's the first thing to do. Did I calculate my bundle of 72, or did I average out on everything? And then the standard's going to say, well, maybe you should be using Cat6A instead of Cat6, bigger wire gauge, bigger conductor section, or different environments, different cable trays, etc. If all fails, if you really cannot manage to keep your temperature and your distances, then your system will be RP2, maybe. Redo your calculations and then check again. And if it's still not good, go down to RP1. In all cases, make sure you arrange your bundles to allow the best airflow possible. Always. Make sure the hot air can evacuate. It's always better. PoE is not an option. You must take it into account from the installation of the cabling. That's what this says. If you want your cabling to be compliant ISO 11801, the installation must be compliant to 14763-2. It's the same one that gives you your separation of power and data, your bend radius, your pulling tension. So, by definition, you must comply to POE, so you must calculate your temperature from the start. Forget the 90-meter permanent link. Because your average temperature in the ceiling plus POE will never be 20 degrees, you can expect your distances to be shorter. If you do not know, if you don't want to go through all the calculations, my recommendation is aim for 80 meters. If you use an 80-meter permanent link, you are covering 99% of the installations. Unless you're doing all of the lighting on POE and everything POE and you have bundles this big, you're not taking much risks. 80 meters will cover most of the installations out there. Some manufacturers will then provide you with warranties on this, or they'll tell you, yeah, but I guarantee more than 80 meters at 40 degrees. They might do this. Hint, the one I work for, of course. Don't forget the contacts of your connectors. These RJ45 connectors were never designed for power. So when you disconnect, it creates electric arc which burns the contacts. There's two standards out there. There's the first one, which was designed to make sure that your connectors could be unplugged, disconnected under POE plus, what was called POE plus, so 30 watts on 2 pairs. And there's the new one now. This is another one. Where is it? Right there, I'm losing it. Okay, there. Okay. 99-002, which is now the one that you want to check if you're going to put POE up to 100 watts, so type 4. Those guarantee that you can disconnect under power without destroying the connector. And then you can get those certificates. The manufacturers will get the product independently certified to guarantee that it's not just their statement, but of course it's been tested by an independent lab. Now, single pair Ethernet. I talked about IoT. And right now, our structured cabling offers Cat6a up to 10G, or 1 gigabit on Cat5e or Cat6, plus power up to 100 watts, which seems great. And we see these diagrams about our POE delivering power for everything that we need. Yeah, but let's look at our needs, really. IoT is going to need 10 megabits, not 10 gigabits, and less than 5 watts. That's the average. And the future IoT, which is today building automation systems, all of these, they're going to switch over gradually. And these are also less than 10 megabits and 15 to 30 watts maximum for most of them. So it's not exactly what we're offering. And then if we look at our POE efficiency, if we want an efficient cabling system which does not waste our power, we need low resistance, which means large conductors, which forces us to use Cat6a. We have to go to Cat6a, which is designed for high performance, 10 gigabits. What we really want is something down there for 10 megs, but high efficiency. This is not our structured cabling today, because what we need is cheap. If we're going to tell the guy doing the HVAC to connect it on the cable, he's going to say, I don't want your gold-plated Cat6a, I want a cheap cable. It's just HVAC, it's not a server. So, our POE invention is great, but it does not meet the needs that we are addressing with IoT. It's just too expensive. So we need something new, which is going to be low data rate, maybe longer distances, maybe a bus topology. And it's already allowed by the standards. If we take the 11801-6, I remember right, and same thing in Senelec, we are allowed to have an SCP, service consolidation point, which is going to be the interface between the structured cabling and the unstructured cabling, the proprietary stuff, or single pair Ethernet. So it was invented in the automobile industry. The cars are already using it. They use 100 meg and 1 gig for very, very short distance in the cars. Yeah, so your touch screen is already connected to Ethernet through that technology. And now what's new is that we can send power on it. So this is what we call Poodle, wherever it is, there. And what we are mostly interested in is the 802.3CG, which is 10 megabits. Remember, that's what we said we need. 10 megabits up to 1 kilometer. So this will come out very soon. September, well, a little bit past September, but very soon. And the objective is clearly stated. It is to replace legacy protocols, all the lists that you saw before. IEC has already standardized or accepted to standardize 6 different connectors. Those 6 are in the process of being ratified. 2 of them already are. The cables are in the process. There's going to be 2 possible channels right now, the 20 megahertz and the 600 megahertz, and each one is available in solid and stranded. Now, you can't use so many connectors, so the 11801-1 amendment is going to state that you should be using one of those 2 connectors. The left one is what people call the LC style, because it is the same shape and size as an LC for fiber. And this one is for normal environment. Nothing specific, called mice 1. The other one here is going to be for harsher environment. You can also use it in normal environment, it's just going to be more expensive. So this is going to be mice 3. It's going to create channels. This is ongoing right now. So we're going to allow 18 to 26 AWG in the standards. Others are possible, but they're not defined right there. And anyway, they would not fit in the connector. You can't make a connector that accepts all cables. There's going to be multiple channels of different distances. So first of all, there's a 20 megahertz channel, which can go up to 1 kilometer with 10 megabits. Then there's a 400 meter channel for 10 meg, 250, and a 100. Then there's the 600 megahertz channel, which should be defined to 100. That's what we're looking at right now. But currently the applications, the IEEE, are only looking at 40 meters and 15 meters. So right now they don't correspond. So who will adjust to who? I don't know. And there's a future something gigahertz for possible higher data rates. What for, I don't know. What frequency, I don't know. We just know that we can make products to go higher frequency, so we're looking at it. But we don't know if it's needed yet. And the current will increase up to 2 amps to provide 100 watts, when currently it's only 74 watts or 71 watts out of the equipment. TIA says things slightly differently. They say already, right now there's only 2 possible channels, the 400 meter and the 1000. It does not mean that they will not create the other channels afterwards, the 250 and the 100. They might do it. And they have already defined that the 1000 is 18 AWG and the 400 is a 23. The 600 megahertz channel is moved to annex. Sorry. They've moved the 600 megahertz, so that's the gigabit. Why? Well, that's because, keep your eye on the target. Our target is IoT. IoT needs 10 meg. TI already said, if you're looking at the gigabit 600 megahertz, that's not the IoT. So we'll put it in an annex. You can do it if you want, but that's not the target. Our objective is to support IoT 10 megs and distances from 15 meters to 1 kilometer. But mostly we will be below 400 and probably much less. So you will not have to pay for the very expensive cable that goes to 1 kilometer just to make some 10-meter links. And the power could be up to 100 watts, but mostly it's going to be below 30 watts. And we already know that if you make a huge bundle of single pair cables, all with 100 watts, you're going to overheat. It will not work. So For sure, we will define some solutions which are based around a lower than the maximum 100 watts. SPE, well, open architecture is the way forward. Nobody wants proprietary anymore. They're sick of it. They want manufacturer A to communicate with manufacturer B. Buildings need a solid infrastructure for the communications, and that is Ethernet. We know it. PoE is great, but at a high price. When SPE, single pair Ethernet, is ratified, and when the products come out, if they come out at the right price with the functionalities that are hoped, then it will be the best solution on the market. If it's the right price and the right functions, it will succeed. But right now, we don't know. The products are not out on the market yet. So, what does this do to our building infrastructure? Well, we always table telecommunications outlets, but now we are talking about service outlets in the false ceiling. Service outlets, that's what's defined in all the standards and the Big C007. Now, if we want to cable all of this, we're adding too much cables. So, we're going to end up with something like this, and your IT rooms are going to look like this. Some of yours already do, right? No, nobody see this. Of course not. So there's a problem. If we add more cable, we will not be able to handle it. So we need to find alternatives. So everybody knows the consolidation point. This gives us flexibility at the user side, right? But it doesn't change our cable issue. The consolidation point means as many cables in as out. So you're not solving the cable issue. We have a solution called fiber to the desk. So fiber to the desk, everybody knows that your computers don't have a fiber card. So some of the manufacturers, what they do is they provide a mini switch. So your computer still plugs into copper. I saw some today with one of the sponsors. That's a great solution. Here's the problem. You can't connect your IoT to this. You cannot connect single pair Ethernet onto that system. So that's not solving these problems. This is making two separate cabling systems. One for the IoT, one for your telecommunications outlets. It doesn't mean that's not what you want. I'm just saying they're separate. Now there's another technology out there called passive optical LANs. You use splitters, you use one fiber, it's the same stuff as fiber to the home. Great solution also. The advantage of this is they actually already have some switches which are for the environment of the ceiling. Some of these products out there exist to put in the ceiling. Here's the problem. You're kind of using a Rolls Royce to do the service of a taxi. You're paying for very expensive equipment to connect IoT devices. So they're not exactly ideal for that application. And anyway, if you really look at this solution, it's just a low-cost version of fiber to the desk. You've just taken some fibers out to make it even lower cost, but in exchange to allow longer distance, because this is single mode. So there's an advantage of distance, but it's just low cost of fiber to the desk with lower performance. So it doesn't solve the issue. So I keep telling you there's no answer. Well, actually, finally, there is an answer. Who knows FTTE? Fiber to the enclosure? Who knows fiber to the zone? Everybody's heard of this? Different words, same thing. Fiber to the zone, you get rid of your cabinet that was, where's my mouse? Over here, and you replace it with multiple smaller cabinets in the office area. Whether you put them on the wall, in the ceiling, in the floor, that's your issue. Just get them closer. Bring the fiber all the way to this. If you do this, you can then have short links to connect your service outlets here and your telecommunications outlets here. The extra money that you spend on your cabinets, you save on the cabling, because instead of having long cables, you have short cables, which again improves your price because of the CPR. If you need a B2CA, you can reduce this because you're not crossing over emergency exits anymore. So this is a pretty good solution. It's also going to allow you to put 25G maybe to the 30 meters in your office, if you wanted 25G base T. Only one thing missing is your current BMS systems are not going on fiber. So you need to add the links between your enclosure over here and your current BMS systems, which will be typically located in a separate room. They're not in the IT room, they're in another one, usually. So you need to add a few links here, copper, most of the time, to be able to maintain that legacy equipment while you switch over gradually. So that enclosure will have a few different functions. It's going to be a CP, it's going to be an SCP, Service Consolidation Point. It's also going to be your wireless SO outlets to connect the wireless access points. And it's also going to be the place to house your gateways. You still will have some gateways for Zigbee, Bluetooth, stuff like this. These work on mesh, but they need some gateways here and there. And we've just heard recently that those gateways might actually be the same as your wireless access point. He could serve two purposes. A lot of this is going to appear in the new revision of the 007 on how to connect things. This is giving you the best flexibility, and it's allowing all the options. But it does need to redesign, and it needs to break the silos. Will people be ready to work together when they haven't worked together in the past? Bigger picture is that our world is changing. All the buildings are based around Ethernet. PoE and the successor Poodle are going to gain momentum. Buildings need to be flexible. We don't want stuff which is fixed. We need to be able to reconfigure the building really fast. It means that we're going towards plug and play. Clearly, even on the cabling, we are going towards plug and play. The architecture of the communications cabling is changing to optimize the flexibility of the building. And this is really what I would insist on, is when you do a design, think of the flexibility for today and for the future. How can you reconfigure it? And this is what you should be looking at today. Thank you very much.